Hey kiddos, today we're going to be talking about dilations. So this is the last transformation that we're going to discuss. We've talked about translation, reflection, rotation, and like I said, this is the last one and it's dilation. And dilation is a transformation in which a figure is enlarged or reduced. Another word we use instead of reduced would be shrunk with respect to a fixed point, C, called the center of dilation, and a scale factor, K, which is the ratio of the lengths of the corresponding sides of the image and the preimage. A dilation with center of dilation C and the scale factor K maps every point P in a figure to a point P prime so that the following are true. If P is the center point C, then P is equal to P prime. If P is not the center of point C, then the image point P prime lies on ray CP. The scale factor K is a positive number such that K will be equal to C times CP prime divided by CP. All angle measures are going to be preserved. So, what is a scale factor? A scale factor is the ratio of the lengths of the corresponding sides of the image and the preimage. So, typically when we find a scale factor, we refer to this formula here, which is new over original, or you can reword that to be new over old. Okay, and this is how we'll set up our ratios to determine what our scale factors are. When the scale factor is a value greater than 1, then that means there's an enlargement. When 0 is less than k, which is less than 1, then the dilation is a reduction. When the scale factor is equivalent to 1, then the images are congruent and nothing actually changes. When we talk about a reduction, another word that we can actually use for that is when it shrinks. Okay, so in order for it to shrink, your scale factor really, essentially, you may want to make a side note here, needs to be a proper fraction. Okay, so in order for it to shrink, it's got to be a scale factor of a proper fraction. In order for it to enlarge, get bigger, then the scale factor has to be a number bigger than 1. And we're talking about positive numbers as well. Alright, so we have some rules for dilation, so we do have some shortcuts here. Two kind of situations. If the center of the dilation is at the origin, 0, 0, then that's going to be our easiest. And what we're really going to do is just we're going to take our scale factor. So remember, K here is representing scale factor, okay? So all you would really do is take your scale factor and you multiply by your x value, and then take that same scale factor and multiply by your y value, and that will give you your P prime, your new point, okay? And that's with a dilation being at the center of, or being at the origin. But we also have a very complex formula, as you can see here, for points that are not the center. So a lot more work to figure out where the new point would be. K is still our scale factor here, as you can tell. So what you would do is you take the x and you subtract it from your center point plus that exact same value, and then multiply that by your scale factor, and then you do the same concept with the y value, and using the b as the center of your to work out this formula. So this will be a little bit more easier to explain when we actually work out a problem. In the instance that we have a negative scale factor, okay, the image and the preimage then are on opposite sides of the center point. So if this would be the center point, then they're going to be on, like it says, opposite sides. So basically the figure rotates 180 degrees, and that's going to be counterclockwise. So nothing absolutely changes when figuring out what the new pre-image will be, because your k is going to be a negative value, but you still multiply it with the x and then the y. Alright, so in our first example, we're going to be identifying dilation. So we're going to find a scale factor of the dilation, and we're going to determine whether it is a reduction or an enlargement. Usually determine whether it's reduction or enlargement is going to be the easiest thing, because you're looking at our image, which here is clearly stated because it's P, and P prime then would of course be our image. This is our pre-image. Sorry, I can't remember if I said pre-image or image. This is our pre-image. This is our image. So therefore, this is our original. That is our new. We know that we're looking for a scale factor. We're going to be setting up new over old. So the new one is a distance of 12 from the center. And you can see here C is being designated as the center point. And our old distance would be 8. If you reduce that fraction, 12 over 8 reduces to 3 over 2. So therefore our scale factor is 3 over 2. And this is an enlargement. Looking at the next one, same situation. Okay, we can see here, since this is labeled P, it is our pre-image, so that is our old, and therefore this one over here is our new one because it's P prime. So when we set this up, we would have the old image distance is 18, oh no, sorry. The old one is 30, the new one is 18. I know it's always new over old, which means it's 18 over 30, which that reduces to 3/5. 3/5. That's a proper fraction, so that leads me automatically to know that this is a reduction. Example 2, in a dilation of CP prime equals 3 and CP equals 12, find the scale factor, then determine whether dilation is a reduction or an enlargement. Okay, so big hint here, because this is our prime, then that tells me that that's going to definitely be the new one, which would then make this one the old. Okay, when we set up, or if we're looking for a scale factor, we should be setting it up as new over the old, or new over original. So our ratio would be 3 over 12, which when we reduce that comes 1/4. Now because my scale factor is a proper fraction, then that would lead me to conclude that this has to be a reduction. So that means it shrunk. Alright, so for this next example, dilating a figure in a coordinate plane, notice I've already graphed triangle A, B, C, and you need to make sure that you do the same. And we're going to graph the image as soon as we figure out what the new points would be, because we are dilating it from the center of the being at the origin, okay, which means that makes it the easiest, and it has a scale factor of 2. And I say that it's the easiest because literally all we have to actually do then is multiply every single x value by the scale factor of 2 and multiply every single y value by the scale factor of 2, and that actually gives us our brand new points. So if I multiply those by 2, A prime would end up being at 4, 2. B prime would end up being at 8, 2. And C prime would end up at 8, negative 2. So let's go ahead and graph that. So that is what the image would look like being dilated by a scale factor of 2, with the dilation being centered at the origin. Alright, so now let's look at an example where our dilation is centered at a point other than the origin. So if you can notice here, I already have a quadrilateral KLM graphed. So please make sure that you do that. And we're going to graph the image after we do this dilation at the center of 1, 2 with a scale factor of 1/3. Now, excuse me, automatically based on the scale factor, I know that this figure is going to be reduced or shrunk, okay, because the scale factor is a proper fraction. Notice we're going to be using that very fancy formula from the shortcut. The use of the 1 here is in reference to this point in the center, the x value in the center, and the reference to the 2 here is in reference to the y value of the center. The 1/3 is coming from our scale factor. So here where you see x goes the original point that we're going to be changing, so I'd plug in -2 there, and then where I see y, I'd plug in the y value, which is 8. So notice I've rewritten it down here, okay, with plugging that in. Now here's very important that you follow PEMDAS. Order of operations is important, okay? So, hopefully you guys know that you have to do what's inside parentheses first. So, -2 minus 1, -3. All right, bring that down. Now, 1/3 times -3 is going to be a -1. Bring down the +1. -1 plus 1 gives me a value of 0. And then now looking at the next value, well, looking for the y value now, you have 1/3 times 8, take away 2 is 6. All right, now if we were to do 1/3 times 6, you get 2, and 2 plus 2 is equivalent to 4. All right, so that's pretty much how you would break down the rest of these points, okay? So using this formula here is going to be important. All right, so for the next one, find L prime, I'm going to plug in the x value of the original L, which is 1, and the y value of that original point, which was 8. And remember, guys, I'm getting the information from right here, okay? So notice the nice thing is everything else stays the same. So now let's work this out mathematically. 1 minus 1, oh, well, that's easy, 0. 1/3 times 0, 0 plus 1 is, so 0 plus 1 leaves me with that being 1. All right, 8 minus 2. Well, hey, I feel like we technically already worked that out, so I don't need to redo all that work again. We already know that the final answer is going to be 4. Okay, so now let's go and move on to the next one, next point. And that is going to be with x being 4 and y being 5. And remember, I'm using the points here referring into to find m prime, so I'm using point m. Okay, plugging that in. So let's work this out mathematically. So 1/3 times 4 minus 1 is 3. Bring down plus 1. 1/3 times 3 is 1. And then 1 plus 1 is a grand total of, yay, 2. All right, next, 5 take away 2 is 3. And then we're going to bring down the plus 2. 1/3 times 3, we already know that's 1. And then 1 plus 2 gives us a grand total of 3. All right, and moving on to the last one. Let me erase all of that. All right, and that last point we would get, all right, 1/3 times -2 minus 1, -3. We've actually, if you recall, we've actually technically already worked this out. So we already know that this answer is going to end up being -1 plus 1 is going to give us that 0. okay? And then with a negative 1 over here for the y value, we get 1/3 times negative 1 minus 2. Well, yeah, what do you know? Negative 3. Bring down the plus 2. 1/3 times negative 3 gives us negative 1. Negative 1 plus 2, though, gives us positive 1. So those would be our brand new points for this quadrilateral. So let's go ahead and make sure that we plot them. And you can see this is what our new quadrilateral would look like. All right, and this final example here is using a negative scale factor. So notice I went ahead and I graphed the triangle here, FGH, with these vertices, so make sure you do that. And we're going to also be graphing the image after we dilate it from the center at 0. Yay! I know you guys are excited about when you see center at 0 because it's super much easier. But this time our scale factor is a negative 1/2. So notice I kind of already wrote here what your shortcut is, or basically how you're going to work this out. And really all you're going to do is you're going to take the pre-image coordinates, which I've written down here for you, and we're going to multiply them by the negative 1/2 to get our brand new ones, and then we can plot it. So let's get to multiplying. So for our new, so for f prime, negative 1/2 times negative 4 gives me positive 2. Negative 1/2 times negative 2 gives me positive 1. G prime, negative 2 times the negative 1/2, which is the scale factor, leaves me with 1. And then the negative 1/2 scale factor times 4 leaves me with a negative 2. And then the very last point, negative 1/2 times negative 2, 1. Same thing again, so that's a 1. So those are my brand new points, so we'll go ahead and graph those. And that is what the new one would look like. So remember, it's also rotated basically 180 degrees counterclockwise. Alright, so for this next example, you're going to graph PQRS first, and then you're going to graph its image after you have a dilation center at a 0, 0. So you have a center at the origin, so that should make it a little bit easier. But notice the scale factor is still negative 4, but no worries, we just did that type of problem the previous one. So really all you're going to do is you're going to write down what the pre-image points are for P, Q, R, and S right here alongside their new points. And then all you're going to do is you're going to take that X value and you're going to multiply by negative 4. You're going to take that Y value and multiply by negative 4 and get your new points. And then please don't forget to graph. Alright, so example 7, finding the scale factor. You are making your own photo stickers. Your photo is 4 inches by 4 inches. So it's probably one of them Instagram kind of photos. And the image on the sticker is 1.1 inches by 1.1 inches. So what is the scale factor of this dilation? Draw and label the photo and the sticker. So notice what I went ahead and did. Here's I drew what the sticker would look like, and then I drew what your original photo would look like. And then remember, we're beginning with the photo, your photo, so that means that's why I put an O here, because this is the old, and we're turning it into this smaller sticker, okay? So old over new is how we set this up. So we would set up our scale factor, new over old always. So 1.1 over 4. And when we reduce that, don't want that decimal there, so move the decimal over. So really this becomes 11 over 40. 11's prime number, yeah, so there's nothing, you can't even reduce this fraction any further. So the scale factor seems like an odd one, but it is not 20, sorry, 11 over 40 would be the scale factor here. Alright, so finding the length of an image, you're using a magnifying glass that shows the image of an object that is 6 times the object's actual size. So with that sentence right there, they just told us what our scale factor is. Determine the length of the image of the spider seen through the magnifying glass. All right, so we actually are given already our scale factor. 6 times bigger. 6 times its actual size. So we know when we're looking for scale factor, it is scale factor equals new over old. Well, we're not looking for the scale factor because we already know it. So 6 equals new over old. Now, I know that we're looking for the new because it says here determine the length of the image. Image is in reference to something that's the new thing, right? Because we know pre-image is the original. So 6 equals basically x over the length of the pre-image, which we do know, 1.5. So to solve, what we have to really do is multiply both sides by 1.5. That cancels out there. And you get 1.5 times 6 is 9. So it is 9, and we're in centimeters, which is what we're talking about. So the length of the image of the spider would actually be 9 centimeters. All right, an optometrist dilates the pupils of a patient's eyes to get a better look at the back of the eye. A pupil dilates from 4.5 millimeters to 8 millimeters. What is the scale factor of this dilation? Show your work. So we went from 4.5, so we started at 4.5, so that's my original. And then we went to 8 millimeters, so there's my new. So we don't know what the scale factor is, so scale factor equals, the new value was 8 millimeters, and the original one was 4.5. And if we are to reduce that fraction, it would then reduce to 16 over 9. So this would have a scale factor of 16 over 9. Hopefully you guys are just, putting this into your calculator and changing it back into a fraction. All right, well, awesome sauce. Adios.